In a previous problem video, we looked at the lump sum compound interest formula for how P0 grows in T years to a value P of T at an interest rate of R APR percent and N number of compoundings of interest. So we've looked at the lump sum problem. And we looked at that problem as what I call like a hopscotch problem on the timeline. Okay, so for example, just quickly, and we will put this formula, the lump sum, in the context of an annuities problem. But for example, if we had $100 that we wanted to invest, an APR interest of 10%, so that would be 0.1 or 10% interest, and an N value of 4, okay, then there is a value called I, the interest rate per period, which is R divided by N, and we're seeing that over here in our spreadsheet to the left as 10%, 0.1 divided by 4 is 0.025, okay? And we want to follow this for 3 years of time, okay? One could draw this as a picture on the timeline, so I'm going to draw a timeline, okay? And we'll have 0, 1, 2, and 3 years time. Okay, now each of those time periods you split up into 4 pieces. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. You'll notice that we have a total of the time times n. In this case, time is 3 years, the number of compounding is 4. We have 12 total time periods. And each of these time periods is a chance for us to earn interest. Okay? So on this timeline, we start with a value of $100, and we want to hopscotch across in time. This is our P1 value. How much money principal, how is the $100 growing after 2 time periods, after 3 time periods, after 4 time periods. And you'll note after 4 time periods, we're at 1 year, right? 4 time periods, 4 quarters of a year is 1 year, okay? And so we were interested in how much was going to happen if we kept bouncing and bouncing, and what was our principal going to be after 12 jumps in time, okay? And this is what we had in Excel. We had the ability to take our principal, $100, right? And we put in an interest rate of 10%, which is 0.1. Number of compoundings 4. We're making 4 jumps in 1 year. The interest rate per period is I, 0.25 or 0.25%. No, sorry, 2.5%. Yeah. And there's our 3 years time period. And the question is, how did we find the value after 12 jumps in time? And if one has a spreadsheet, we can do this jump across. So let's look at the value, how much we have after 1 jump in time. So here is P0 of 100. I'm going to take the P0 value and I'm going to multiply it by 1 plus I. What we're saying here is that P1 is equal to P0 times 1 plus I. Okay, the amount that you have after 2 time periods is going to be the previous value, P1 times 1 plus I. P3 is equal to P2 times 1 plus I. And we keep going until we get to P12, right? How much is the account worth after 12 jumps? This is what we're going to do in Excel. Okay, so we have now our P1 value. We've made 1 jump from 100. Let's go to P2. The previous value, 102.5 times 1 plus the I value. Okay, And if you're getting the hang of this, right, you can see in our formula that I've got my previous value multiplied by 1 plus B $4. The $4 is going to be an indication that we're always multiplying by this I value, which is in the spot B4 in the spreadsheet. Okay, the reason you want that $ is because one can now, once you've got the formulas in, you can drag and drop for these number of time periods. This is 1/4 of a year, and in each of these time periods is 1/4 of a year long. So we have 12 of these time periods in 3 years. So let's look at the value of this account if it grows according to this. And you'll notice that we get, after 12 time jumps, P12, right, is equal to $134.48. Okay, this also happens to be the same thing as putting into your formula the principal after 3 years is 100 times 1 plus R, which is 0.10 divided by 4 to the 4 times 3 power. And if you compute that number, you will get the same thing, 134.48. So the question is, if we have a formula for the amount of the principal at any amount of time, if there's a formula for it, why do we need to keep going the different jumps in time? Why do we need to see these 12 steps, right? And my claim is that the reason we want to see these 12 steps across in time is because we are now going to bring in the annuity problem, we're going to bring in a new value, which is called R. And the annuity problem is to bring in an amount. In this case, we'll say 25. This is $25, and this is the amount that you are going to deposit every 1/4 of a year. So right here, 1/4 of a year, and we're going to say at the end of that year. So notice that this P0 value, what I want you to do is allow the P0 value to grow and gain interest. And then right here, I want you to also add the R value. At the end of the year, we're going to pretend that we've deposited money into the account. Okay? And then you're going to let that amount of money, P1 plus the deposit, that is what's going to grow, right? And then you're going to make another deposit of R dollars, and that amount of money is going to grow. And after you allow that amount of money to grow in interest, you're going to then add in your deposit, and we're going to keep working our way across here by adding in R dollars, right? And there would be 12 of those times. We made 12 deposits of R dollars. Okay? And the question is, how much do we have in the account, P of T, the principal in the account, if there's going to be 2 contributions from this, right? That P0 grows with interest, but then there's also going to be a part where we're adding in R dollars, right, every 1/4 of a year. But then this part also grows plus interest. The interest is growing on the payments. And this currently is what we don't really have a formula for yet. That doesn't keep us from figuring out the Excel spreadsheet. So let's see what would happen. How much would we have after 3 years if we deposited $25 to our account every 3 months? Because then it's 4, so that'd be every 3 months. So let's go back to our spreadsheet. We still had the $100. $100 is going to grow. Okay, so let's go to this formula and say that $100 is going to grow in interest, And then after it's done growing, this is when I'm going to add in the R dollars, add in the $25. And now you can see that I have $127 after this time period. Now let's look at this quantity, right? What we're going to have is after we made our deposit, this amount of money is going to grow with interest. But then after it's done growing with interest, we are going to add in the $25 again. Okay? Are you seeing the pattern here, how this is working? Okay? Let's go to the next value, okay, and look at what it should be. It should be the amount that we grew previously, that B10 value in orange there. That's going to grow via the interest rate per period, and then we're going to add on the payment after that is done growing in interest. Okay. So here we have a formula. We are we've got a formula going, and now that we've got it, we can just drag and drop it down up to. Let me go back to that. Maybe I didn't have something right. B10. Oh, okay. So watch this. So do you see? I always need to be the $25. Always needs to be B5, B5, B5. Right? But when I drag that formula, B5 became B6. And that is why I need to make sure that I put a $sign on this to make sure that this number is always the one in the B5. Okay. Now watch what happens when I drag this down. Can you see that my next formula is growing the orange value, the previous one, and then adding on the appropriate $25 amount? Okay. So now we can drag and drop our formula and see how much we are going to have after 3 years of time. Okay, if we add in, I'm sorry, I should be doing this in orange. We're getting different. If we're getting different values, the ones in orange, P1, is the $100 growing, right? And then we are adding in the $127.5. So we added in the 25. Now you can see that P2 in orange here, because we've taken into account our payment, is $155.69, right? And if we continue on with this process, P12, the orange ones are taking into account the payment, you'll see that you have $479.37, or 38 cents, I guess, right? So this is the effect of the payments that you make on a regular time period. Okay, one can do these in Excel and have a spreadsheet. I'm not sure yet what formula we're going to need to use, right, to get that 479, and that's what we need to develop in another video. Okay, so I think what we can see here is that this is a pretty good number. Let me see. Notice that our P0 value was $100 out of your pocket. Okay, so you had to find $100 to get this started with, and then you had $25 times 12. You also needed to come up with $25 a month, $25 every 3 months for 3 years. So that's 25 times 12. Whoops, sorry. I'm trying to figure out how much out of pocket we had to come up with. That was $300. Okay. So you can see here that the money that we had just out of pocket was $400, right? But after 3 years, can you see that we have an additional $79.38? So what we have is an additional $79.38, and this money is coming from interest, from the compounding of interest, and we're getting interest compounded on the amount of money that we are depositing. So this is a good start. And in the next video, we are going to look at how to develop a formula to jump right to this number 479.38. That will be the subject of the next video.